Continuing on, this is question number 24. And for this one, we're looking at a line graph. And we're asked which of the following conclusions does the graph support? So notice the graph is about wind speed. This is the wind directions written across the bottom of the graph, like north by northwest, north, northeast, and so on. And then the miles per hour is over here on the left-hand side. So first part, winds from the northeast cause wind speeds to increase. Okay, so northeast, I'll look at this, and I've got here this value and this value, and the wind speed is not increasing here. Notice that from this point to this point, that the wind speeds are actually decreasing. Part B, wind speed is not impacted by wind direction. Well, I can't say that because it looks like the wind direction does have some kind of effect on how fast it's blowing. And then part C, the highest wind speed was recorded with winds from the west. Okay, so I look at winds from the west, and that wind speed is up here at 14 miles per hour, so that's true. So this is a true statement. We'll choose that one. The lowest wind speeds were recorded with winds from the north. Okay, so winds from the north, that was this one, and that's not the lowest. The lowest is northeast. So the correct answer for this one is C. The highest wind speed was recorded with winds from the west. Okay. And problem 25. We're using the data represented in the graph below, still talking about wind speed and miles per hour, but notice we're not looking at direction this time. We're looking at days of the week. And the question in this one is, what is the mean wind speed? Okay, so we're looking at the mean value. Now, mean is the average. So what we want to do is we want to take all these speeds here, the 10 miles an hour, the 7, the 9, and so on. And we're going to add all these speeds up and then divide by the number of speeds. Sorry, my pluses and numbers are running together. There were 7 that were taken here from Sunday through Saturday. And when we do the arithmetic, 64 divided by 7, that gives us about, and notice the problem here says round your answer to the nearest tenth. So that's 1 decimal place after the decimal point. So that's going to be about 9.1 is our answer. And that is miles per hour, 9.1 miles per hour. That's our answer. Then in question number 26, we'll scoot this up a little bit so we can see it. If a yard has measurements shown in the diagram, what is its perimeter? Now, perimeter is different from area. Perimeter is the distance around an object. Okay, so we're looking for perimeter here. And they tell you to make some assumptions. Assume the angles that make the rectangle shape are right angles and the triangle has 2 equal sides. Well, if that's the case, and we just insert a little segment right in here, straight down, then we have this rectangle, which is a 15 by 32. So that's 15 plus 32. We're looking at distance going around. And they tell me these 2 sides are the same, so this has got to be 7. So that's 7 plus 7. And this opposite side here has got to be 32. Now, we're not going to count that segment that we drew in there. Just the segments forming the edges of this shape. So when we add all that up, that gives us 93 feet. And that's our perimeter. That's the distance around that figure. The next question that asks for the range in a data set. Well, range in a set of data is simply one number. It's the maximum value subtract the minimum value. It's not like from something to something. It's not like that. It's max subtract min. So in this problem, as I look over all my numbers here, the maximum looks like it says 42. That's the highest number. And the minimum is this 4. So to find the range, I just subtract those two. 42 minus 4. And the answer for that is going to be 38 is the range for this set of data. Then for the next problem, 28, which of the following is an example of a positive correlation? Okay, so as I'm looking at these, this question, the part A, says decreasing the time. Okay, so decreasing the time spent getting ready in the morning allows more time to sleep. Well, that's two different directions, right? Increasing a car's fuel efficiency reduces its carbon footprint. Increase, reduce. They're different directions. The higher the down payment on a new car, the lower the monthly payment. It's two different directions. The higher the temperature outdoors, the more ice cream is sold. They're both going in the same direction, right? One's increasing, the other's increasing. So as one increases and the other increases, that's called a positive correlation. Okay, so we want to look for those key words. That's question 28. And let's look at question 29. In question 29, it says an employee works 35 hours last week and earned $367.50 in hourly wages. How much will the employee earn in hourly wages this week if they work a total of 27 hours? Okay, so he worked 35 hours last week. 35 hours, and he made $367.50. This week he's working 27 hours. How much is he going to make? So this is a proportion. We're just setting these two ratios equal, and we're going to cross multiply to solve, right? Okay, so as I do that, I get 35x equals, and multiplying 27 times 367.50 is 9,922.50, or 0.5. And then I want to get x by itself, so I need to divide both sides by 35. And my solution for x then is going to be $283.50. So that's how much he should expect to get paid for 27 hours if he's working at the same rate of pay. I'll stop for there.